Example 2. Assume that adults have IQ scores that are normally distributed with a mean of 100 and a standard deviation of 15. So we have parts A through C. Part A, find the probability that a randomly selected adult will have an IQ score above 120. And then parts B and C, we have a group of 9 adults above 120 and a group of 25 adults above 120. Go ahead and pause the video here and see if you can work this one out. Very similar to example 1. Okay, we're going to begin by drawing and labeling a normal curve. We have that all labeled. We're going to use the calculator here to crunch this out. Lower 120, upper 1E99. The mean is 100, standard deviation 15. And so we get this area here of 0.0912. So part B, find the probability that a randomly selected group of 9 people will have an IQ above 120. So this group of 9, that should tell you, let's go ahead and find the standard deviation of that sample mean. Sigma over root n, 15 over square root of 9 is 5. Go ahead and draw, shade, and label the normal curve. And we're going to put it in the calculator. Exactly the same thing we did before. The only thing that's different is that standard deviation. Remember, my variability decreases as I increase my sample size. And I end up with 3.17 times 10 to the negative 5. Very small, so this is not drawn to scale at all. Again, I just use this model to kind of help me think through the problem. Okay, part C, very similar. The only thing different here is now we have a group of 25 people. So what's the probability that a randomly selected group of 25 people will have an IQ score above 120? We find the standard error here. Sigma over root n, 15 over square root of 25 is 3. And I'll go ahead and draw and label a normal curve. Okay, everything again is going to be the same with the exception of my standard deviation. The other numbers stay exactly the same. And I end up with 1.315 times 10 to the negative 11.